What happened to the iconic rings of Saturn? Its stunningly beautiful and mysterious halo has been a source of fascination for centuries. But what would happen if it were to fade away? For thousands of years, Saturn's rings have captivated the minds of everyone, from astronomers to everyday citizens. But now, thanks to Cassini's mission, we may finally have clues as to why the rings are fading away. In this video, we'll explore the evidence that suggests the possible age of Saturn's rings and discuss how Cassini's missions has given us insight into their mysterious origins. Let's get started. Saturn's iconic rings have captivated astronomers for decades, but now researchers believe they may be fading away. A recent analysis of data from NASA's Cassini mission shows that the particles that make up Saturn's icy rings are being pulled apart by the sun's radiation and gravity from Saturn, leading to a gradual decrease in their size and density over time. Scientists estimate that the rings could disappear within a few million years. To learn more about Saturn's rings, astronomers are examining the data from Cassini to try to uncover their origin and better understand the physical properties of our solar system. This will help us understand how planets form as well. It's been long predicted by NASA that Saturn's rings are indeed fading away. The sun's powerful radiation and the planet's own gravity are slowly ripping the iconic structure apart, a process that could take as little as a few million years to complete. To put this into perspective, the scientists estimate that the rings are only about 100 million years old, and the clock is ticking. So what exactly causes Saturn's rings to fade away? The answer lies in a combination of gravitational and solar forces. First, the sun's ultraviolet radiation bombards Saturn's rings with powerful waves that cause tiny particles of ice and dust within the rings to break apart. Over time, these small pieces become smaller and smaller and eventually get drawn into the planet's atmosphere, making Saturn's rings appear thinner. Secondly, the gravity from Saturn itself pulls on the material within its rings and causes it to break apart more quickly. This is due to a phenomenon known as gravitational shearing, which occurs when two bodies of unequal mass are orbiting around each other in close proximity. In this case, Saturn's rings are pulled inwards by the planet's immense gravity, leading to their gradual dispersal. Fortunately for us, the process of Saturn's rings fading is very slow, and even with the current rate of deterioration, it could take an estimated 300 million years before they completely disappear. A reassuring thought for those of us who love gazing up at the night sky. Until then, we can still marvel at the beauty of Saturn's rings and how they've enthralled humanity for centuries. Cassini's mission has been instrumental in giving us insight into the mystery of Saturn's rings. Launched in 1997, it sent back incredible data and images that allow scientists to learn more about these iconic features. The planet-orbiting spacecraft gave us an unprecedented view of Saturn's rings, unveiling their complexity and offering clues as to their origin. Cassini's ultraviolet imaging spectrograph UVIS was able to take highly detailed images of the rings during solar occultations, allowing us to measure the size and composition of the tiny particles that make up these iconic features. With this information, we can gain a better understanding of how planetary systems form, giving us insights into the origins of Saturn's rings. Moreover, the mission has allowed us to learn more about the physical properties of our solar system, leading to a better appreciation and understanding of this unique celestial body. The Cassini mission was groundbreaking exploration of the Saturn system that started in 2004 and lasted until 2017, when it plunged to its death into the planet's atmosphere. During its 13 years of detailed observations, the spacecraft was equipped with an instrument called an ultraviolet imaging spectrograph, UVIS, which took 41 incredible backlit images of Saturn's rings. These images allowed scientists to better understand the optical depth of the particles making up the rings and ultimately learn more about their size, composition, origin, and collision activity. UVIS was particularly powerful as it could detect dust particles at a micron level, giving us insight into some of the smallest particles in Saturn's system. UVIS can use the sun's light to measure optical depth, a measure of how much material absorbs that light. This helps scientists determine the size and composition of the particles making up Saturn's rings. This is important because it can help us understand more about the origin, collisional activities, and destruction of ring particles within our solar system. The ultraviolet imaging spectrograph, UVIS, On board the Cassini mission was specifically designed to detect dust particles at the micron level, allowing for very precise measurements of optical depth. This data was then used to infer the size and composition of ring particles, helping us better understand their origins. With this information, researchers are able to paint a better picture of the formation and evolution of not only Saturn's rings, but also other ringed planets in our solar system. The mysterious origins of Saturn's iconic rings have puzzled astronomers for centuries. While the Cassini mission might have ended, its data continues to provide valuable insights into the formation and evolution of this stunning planetary feature. Evidence suggests that the rings are relatively young, estimated to be between 10 and 100 million years old. There are two main theories as to how the rings could have formed. The first theory suggests that they are remnants of a destroyed icy satellite, while the second proposes that they are leftover pieces of a comet that was disrupted by Saturn's gravity. Although both theories remain largely unproven, scientists continue to use data from the Cassini mission to better understand the dynamics of Saturn's rings. Saturn's iconic rings are made of particles ranging from a few inches to as small as microns in size. However, the exact composition and origin of these particles remained a mystery until NASA's Cassini mission. By studying the data gathered by Cassini during its 13-year-long mission around Saturn, scientists have further uncovered the many mysteries of Saturn's rings. Cassini has provided us with critical information about the size, composition, and origins of these particles, as well as the evidence on whether they are fading away over time. The knowledge gained from this mission will help scientists understand not only more about our solar system, but also how planets form in general. Understanding the formation of Saturn's rings could also provide valuable insights into the formation of planets. By understanding how rings form, we can gain a better understanding of the collisions between objects that lead to the formation of larger particles. This knowledge could then be applied to a greater context and inform our models about planet formation within our solar system and beyond. Studying Saturn's rings could also help us understand the physical properties of our solar system and the environments into which planets form. Scientists have already been able to use Cassini's UVIS to detect dust particles at the micron level, allowing us an insight into the smallest particle sizes in Saturn's rings. This data can then be used to shed light on some of the mysteries surrounding planet formation. Ultimately, understanding the formation of Saturn's rings could provide us with a deeper insight into planet formation and help to further our knowledge of the physical properties in our solar system. The Cassini mission was an incredible feat of engineering and science. But it's not the last mission we will have to Saturn. In fact, there has been much talk lately about a new mission known as Dragonfly, which aims to explore the moons of Saturn in search of potential life and sources of energy that may help us learn more about our solar system. This mission has been proposed to launch in the mid-2020s and will be powered by nuclear energy, with its primary goal being to explore Titan's surface. With this new mission, we may yet learn even more about Saturn's rings and their future potential for fading away. We can only wait and see what the science of tomorrow brings. Until then, we can enjoy the marvel of Saturn's beautiful rings while they last. As we continue to explore our solar system for answers about planet formation and potential sources of life, it is clear that understanding the dynamics of Saturn's rings will be a key component in helping us unlock the mysteries of our universe. With the upcoming Dragonfly mission, we may yet be able to uncover even more exciting information about them. What are your thoughts on the Dragonfly mission? Let us know in the comments below. Thanks for watching. See you in the next video.